Hi, hi.
Hey, Chisu, how are you?
Yeah.
All right. So I'm gonna start by sharing my screen.
Hmm. Yeah, and could you play recording when you do the example?
Yeah, it's already recorded. So we
Okay.
should be good to go there.
Okay. Got it.
All right. So as you know, I guess I go from the beginning. If you ever need to find the code, it's gonna be at this GitHub repository here. Oops, that's not right. So the code is going to be at this GitHub repository here, GitHub CCRU net/traffic rec. And it'll have all the code and at least all of the Python scripts for it. The one that runs everything is this guy here, that main in packet rec 8.4. Now that changes each time I do an iteration, so it'll probably change again before you run it, because I'm doing like updates on it. Here are all the one that says NN. Those are all my different types of neural networks that I can use to run it. I'm going to show you how to run 2 files today. That's going to be the automate sequence list, as well as the main packet recognition file. All right, so what I'll do is let me just open a brand new session here. So I run all my stuff in what's this thing called MOBA Xterm, and I do that because I can run multiple windows consecutively, but you can run it in whatever one you want.
Okay.
So here's my thing on iLabs. I already have the information stored. So I'm going to CD into that repository. I have it in what I call wired. You'll see I have a few folders here. The code folder, that's where I have everything stored. So if I go to my ls code, you'll see that it has all of the files that I need to run the neural networks. That's kind of just where I have it stored. So the 2 files we're going to deal with again are this guy. That's your main one that you just want to run a single test. And this is a new one I created for automating through the sequence list. All right, so once you're in the directory that you want to be in, I have a Singularity shell that has all the drivers and everything that I need to run the code. And that Singularity shell, so I always go Singularity shell, and then I open that up. It's this GNU radio file here, right? So that's where I run everything. So the first thing I do is once I log in, I get to the folder that I want, is I go ahead and run this shell with this script, which I have labeled as GNU radio-curious.sif. So now that I'm in that Singularity shell, that means I have all the drivers that I need to run the code. So it's in Python, actually in Python 3, I think Python 3.6 or something like that. So make sure when you run the script, you always start it with Python. And like I said before, I have it saved in my main directory here for the neural network packet recognition. So there's a bunch of stuff in there. Like there's a bunch of kind of overhead and a lot of logic because of all the transition stuff that I went through, and I wanted to make it as flexible as possible. So if you ever want to see a list of all the commands, you can either type in -H, or you can type in ~help, right? And it'll show all the commands that run the particular code. All right, so these are.
I got a question about Singularity. Does that mean like you use Singularity to set up all the environment for this one?
Yeah, so it's a Singularity shell, and that means it has everything that I need in terms of the environment to run it. So it has all the drivers that I need for Python. Like the big one was Keras and TensorFlow. I also recently just installed new drivers on there to run some of the more recent networks. And an interesting note is if you need to install stuff, you can actually like install it or update it using like pip install and it'll then be saved into that environment. And then anytime you run it, it'll have a list of all those all the files and stuff that you need.
Okay. Oh, so if I like run this first time, like I do like run the code first time, I should like install all the dependency.
I would recommend just running the Singularity shell. I would recommend just taking Singularity and just opening that up and always running it in there. You can install all the dependencies. That usually is a little bit more difficult. And if you're trying to do it on iLabs, I don't know if you have the permissions to do that. So that's one of the reasons we created that container, so you don't have to install it. Everything's already there.
I got it. Okay.
All right, so there's a bunch of stuff here. I'm not necessarily going to explain everything. I'm just going to give you an overview, and then if you have different questions, just let me know.
Okay.
Your 5 main components are your training folder, your test folder, what's called the log file. Where's the thing for that? Which is here, the log file, and then your samples and the number of samples and the number of points per sample. Now, the reason I broke it up like this is because when you are dealing with neural networks, you have 2 phases. You're going to train the data and you're going to test the data. I ended up separating them because sometimes you want a different training set than you do from your test set, right? So I have actual folders, and there might be like, remember when I had you create like 2 files, right? For the website stuff, you have a training file and a testing file. And the reason I did that is because it makes it easier to really get a diversity in terms of determining how effective the network is, right? Because if you're constantly texting a network among the same files or the same data, your accuracy results could be a little bit skewed. So when I do that, just keep in mind that you want to keep everything in one folder. You can have subfolders, like for example, my modulation data. Let me see, I'll take a look at that. So right now, if I take a look at the data for the website, I have it here in this, under the wired, I have something called the data folder. I have a neural network test data here, and the main Ethernet folder is where I have the information, right? So you'll see I have a few files here. I have test 1, I have train 1. So we'll take a look at that. And what that is this is the data that I'm using for if I want to just look at 10,000 samples, right? That's why I just have it here in this folder. If I look at a different one, which is the test folder, you see that the files are doubled. So it has just a little bit more information if I wanted to test it with more data than initially. But the important part is just that you have all of your training files in one folder and have all of your test files in one folder. Now the program is flexible where I can say I want to train it and test it from the same folder. So you have the option to do that. You just have to make sure you list it as you run the program.
Okay.
All right, another component. So we have our folder, right? You have your training folder, your testing folder. Another vital component is what's known as the log file. So let's go ahead. I will open up a log file now. So you see I have a bunch of log files here. So I'll open up the one here. All of my log files I save as a CSV, and that's needed for the networks to distinguish between what the files are. So in that I have like the labels, I'll have different parameters, like what if I'm testing noise or power, and I want to include that as part of my parameter, then I have that in there, right? So if I take up the log files for this, what you'll see is the first one, it's just going to have this file name, and then it'll have all your file name information. What I have here is labeled as S1 mod because that's what I started the parameter with when I was doing the modulations. You can change that if you want. Just make sure that you update it when you're running the program. So you'll see this in that S1 mod column, right? I have SCP, YouTube, NYT or New York Times. It gives me the type of data that I'm testing, right? For every file, I need to identify, what class it's in. And that's what this second column does. So if you were to open this up, if I were to open it up in Excel or open it up in Google Sheets, that's kind of where you would see it. And let me see, do I have this stored up here? And then it goes down. This additional information is like for additional specifications. I'm not using that right now because I don't need it. But if you wanted to add, maybe you want to put in, I don't know, number of packets or something like that, you can add that information in here. So I do have a little script that I was using to create this, but for just to save time, I ended up just editing it on the fly. Like if I had another file, let's say we wanted to, you copy one more file here, right? So what I do is if I want to update it, you can always go down here to the end and just add new data. But make sure every time you add a file that you update your file, update the thing you want to put in there, right?
Oh,
so
you
let's
mean
say,
for each time when I add new data in the like the test list, I will update the log file.
right. You just want to update the log file. Also, so you see how I did, let's say if you had 2 more folders, you did maybe 2 more things for the NFL site, right? And you called them NFL 5 and 6, right? So I just copied and pasted the same format that I had here, added it to the end of it. And that means that now it'll be able to recognize that file and also tell the type of file that it is, right? If it was a different one, let's say it's not, I don't want to put this in an NFL class. I want to put this in a NFL 2 class. Whatever you want to do, you can go ahead and update it here, right?
Okay. So is that should be like the same sequence in the folder? Is that the sequence matter? Like,
no, it doesn't matter the order that it's in, just as long as you keep the format consistent, right? You want to make sure that it starts with this comma and it has the same number of columns and stuff like that. But the order doesn't matter because when I read it in, I'm doing a pandas read in, and it's fine with parsing through and sorting through the data.
Okay, makes sense. Okay.
Now, what is important is you don't want to have the same file listed twice, so that no duplicates. It should just be one, it should just be listed one time because it'll error out if you have it on there twice. All right, so I'm going to leave that on there and then go ahead and exit this. All right, so I keep it here. If you wanted to use a different log file, that's fine. All right, so now let's go back into really how we want to test it, right? So anytime I want to run it, right, I say Python 3, you can do like this, dot, blah, 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 you know how to run Python files. All right, so for every parameter that I want to test, I'm going to add that. I always start with my folder train. So that means what is my training data folder, right? And then I can go ahead and locate that. And we'll do, all right, so I put my information in for my training folder. I'm also going to need my test folder. Oops. All right, so now I have this. I have my training folder, my test folder, right? The next thing you need is your log file. Oops. Data. Okay. Oh, because You got to do a dash dash and then the actual parameter that you're going to be testing. All right, so I have my log file and I'm going to do all right, so now I have my training folder, my testing folder, my log file. Remember I said the other parameters you're going to look at is your number of samples. So when I tested it, right, we were looking at it, for the first one, my number of points, I always set that to 1,000, right? That means how many IQ pairs or how many timing / packet pairs am I going to collect per sample? So I'm taking 1,000 of those, individual packet timing, packet length samples. That's what that means for my number of points. Right, so I just by default just set that to 1,000. And then the next thing you want to put in there is your number of samples. So the number of samples means how many samples per file do I want to collect. So remember I was saying before, that's why I had to be 77 megabytes because I wanted to be able to take 10,000 samples per file, right? So I'll set that to 10,000, and that means for every file, it's going to take 10,000 of these 1,000 point samples for each of that. You with me? Okay, so now I have these 5 main components. The next one is the big one, and that is the type of neural network that you want to run. Now I have a bunch of networks on here. The main ones that you're probably going to be running is the fully connected and the convolutional neural network. If you ever need to be reminded of all the networks that are on here, you'll see this neural networks function, and it'll list all the ones that are available and then how you can classify them, right? If you wanted to run the fully connected, right, you just put in this FCN. For the CNN, that's the abbreviation for it, etc. Now you can actually run multiple networks in a row, but I typically just run one at a time. So for my neural networks, let's say I want to do the categorical one, and I'm going to change my samples from 10,000 to 1,000 just so we can see it run pretty quickly. All right, so now I have my neural networks. I have the number of samples. Last but not least, you're going to do something called the stack type. Now, this is used to make sure that the way that it's interpreting the data is optimized for the type of data that you're receiving. Because I use this for modulation data, I use this for other information, sometimes I have to just manipulate the data a little bit differently. So for the Ethernet data, the stack type should be ETH. And what that means is it takes it and it normalizes it. It divides all the data by Q, which allows me to maximize the accuracy. If I don't do that, the accuracy for my network is a little bit lower. I'm sorry, not Q. It divides it by the packet length.
Packet length.
Yeah, it takes all the information on there and divides it by the maximum packet length just to normalize the data. So that's what this stack type is. It basically normalizes the data, and it's going to be different for each thing. If you'll see, I have 3 different types on here. I have the for the modulation recognition, you're going to do like a pair or whatever. For the Ethernet, you're going to do something called stack. So that's what you're going to do for all the web data. All right, so once we have that, I'm trying to think if I need anything else. If you want to, well, I'm going to run it. So hopefully we won't get any errors. All right, awesome. So this is running. You'll see it. It'll give you like an output of all the networks and all that, which you're probably not going to be as concerned about. For each epoch, it's going to list what it's running out. Ignore the accuracy here because that's not really the final accuracy. And at the end, hey, why is that so low? Huh, interesting. That is really low. All right, so the output of this will always tell me what that what the final accuracy is as well as the loss. Now, I'm wondering why the
Maybe because the
accuracy.
sample number is 1,000. So
Yeah, but even with 1,000 samples, it should not be. You know what? Okay, that's about 10%. Okay. Yeah, it's gonna be like that because I'm using 10 websites. So okay, that's fine. That's a really good point. If I change to 1,000, it'll probably increase it slightly. So let me. Oh, and you know what? Also, I'm sorry, I forgot. So there's another parameter in here because I have so many files. Remember when you did the STP data and the YouTube data and a bunch of other stuff? I have that all included in this folder. So I have something called an exclusion parameter or an inclusion parameter. And what that does is it allows you to tell the networks which classes you want to test for. And I'm going to include that in this folder. I'm going to include that in this test just so you can see how that functionality works. All right, I don't think this is going to improve it a lot, and that's fine. And you'll see, of course, as you run it with a larger sample size, it's going to take it longer to run.
Yeah, by the way, last time I heard you say like for training data, like maybe spend like couple of days to train it, like this is what process.
Yeah, that's if you have a really large training data set. So when I said it took a couple of days, that was for like the convolutional and the LSTM, and I had like millions of samples, like I think 2.4 million samples. So it took a really long time. It took like 3 days. But for your website data, I don't think it will have that. I don't think you're gonna have like millions and millions. So it shouldn't take, days. So remember I was telling you about, I'm gonna do this just so I can remind myself. The final thing is you want to make sure you include the classes that you want to test. Folder, number of points, sequence type, sequence parameter. You're gonna keep that on there, sequence test. All right, so for the sequence that you want to test or the type of test you want to do, we're gonna put in, I'm gonna change that so that we can just test for certain websites, right? So I'm gonna do something called the sequence type. Now, another way you could do this, because if this gets too complicated, you don't have to do that. What you could do is just create a folder with only the files that you want to test, right? So if you don't want to specify that I only want to look at the CNN and the Amazon data, all you have to do is just create a separate folder with just CNN and Amazon so that you don't have to use this this inclusion parameter here. I just included it so that I would be able to tell what I'm doing. All right, so here's a sequence type, right? So I'm going to do sequence type, and I'm going to list it as inclusion. Sequence test, this is going to tell me what websites I want to actually test. And you'll notice that as I do this, you're going to see the accuracy improved vastly. So I'll do CNN, New York Times, and NFL.
So sequence test mean like in this case, like only test three data from three sides, right?
Yep. Yep. And that's going to be, just make sure when you put the type, you put INC if you're going to do that, meaning I want to include these. If you made this if you want to keep these out, meaning you want to exclude those, you can do EXC. But for that, we're going to include that. So, and you'll see that it'll update the arrays here. Slice is not tuple. Oh, I think that this needs to be lowercase
Okay.
because my things are lowercase. I should fix that. I'll try to fix that. So now it should work. All right. So you'll see here, this is telling me I'm including these classes. I'm going to go back up. I'm only including these 3, and it's excluding or it's kicking all these other ones out of my data.
So they will have higher accuracy.
Right, right. And you'll see the accuracy has improved a little bit.
Is that 33%?
Yeah, it's 33%, which is still relatively low. I don't know why it's so low. But I mean, I think you get the idea. I'll figure out why it's so low right now for some reason. I don't know why it's so low. But this is kind of just how to oh, you know what? Let's try one more thing. And I'll run this. So this is the network that we want to use is the FCN network. And I'll go ahead and run this for 1,000 samples. I know it's shorter, but I want to test something out real quick. But that's, I mean, you have the basic structure here in terms of how you can run it. And that's it. The other program, all right, so remember I said there's 2 files. This one right here is that main, main and end. There's also something called the automate packet recognition. So right now, it collects the data for those 3 sites all at once. But let's say, so one of the tests I wanted to run was to be able to just do, you know, 2 certain number of sites at a time, right? 2, 3, 4, and just kind of increase that. So if you find that you want to do that, you can use this program to start that up. It takes the same inputs as the other program. And what you'll see is I'm going to include a bunch of other files in here. All right, so let's see, I had Amazon. So Amazon, Fox, and eBay. All right, so now I'm saying I want to automate this, right? I want to include these files, and I want to start the list where I want to include my sequence at the second parameter. So that's what this sequence start means. So now what you'll see is you're going to see it cycle through. Right, the first one is just going to do these. It's only going to include these particular those sites, right? And then as it increases, it's going to include more. For the next one, it's going to include all 4 of these, and then it's going to be followed by the final one, which is going to have all 5 of those websites. So that's what the sequence does. It allows you to take the list that you're looking at and look at them in order. You have questions?
So the accuracy is like 0.1185. So
Say that again.
I mean,
Oh, why you're saying why is the accuracy so low? So remember, for this one, as we're testing these, when we increase the number of websites, the accuracy actually decreases. So if I wanted to
yeah, I
increase
mean,
my
I remember like in the graph you showed, like it would be like 70%.
so if we want to do 70% accuracy, right, that's going to be 70% accuracy for the same test conditions, right? So let's see, if I go to Ethernet test, Ethernet train, and again, that's going to be for the CNN data. So I can do that. It's going to take it a little bit longer to run. And what I'll do is Amazon, I think Brit, where I started, Brits, CNN. So I started them in alphabetical order, right? So let's try that. We'll take it out there. And so we'll see if we can get that high accuracy here. Now notice that I changed my network from the FCN, or I will change the network from the FCN to the CNN network. This is the one that has the highest accuracy. Now, the CNN network does take longer to train, right? So as I do this, what you're going to see, and let me just check something really quick. What you're going to see is that where the fully connected network was really fast, this one is going to be it's going to be a lot slower, but it will function. It's just going to be slower.
Okay.
Okay, so I just wanted to make sure that I would start with those two. All right, so this is what we're going to do for this guy, Amazon, Brit, CNN, eBay. So we should get higher accuracy results. Now my number of points, oh crap. Number of points is not the number of points, it's your samples that you want to be at 10,000.
Yeah, okay.
All right, it starts with those two sites. All right, and you already see this accuracy is already higher.
Oh, yeah.
But you also see that it's taking longer to train. So that's going to take a few minutes to actually run and complete. But I think the reason that fully connected was so low was because I was testing it with the wrong thing. So what I'm going to do is I'm going to let this run. I'm just going to go over to a new window. Not that one. All right, here's my data folder. Anytime I run this test, it creates a folder called results.
Automatically create a folder.
Yeah, if it's not there, it'll create it. And every time it runs a test, right? So let's just cd into this results folder. Every time it runs a test, it'll create a file with it's a date loaded file that'll tell you all the results from it, right? So let's go ahead and look at let's look at the one that we just created for today, and this will have all your accuracy results. 429. All right, so if I open up this results file, you'll see it has all of the information for the stuff we ran. It's going to be hard to read it like this because it just looks kind of messy, but it's a CSV file, and you'll see it has like the different accuracy points and all the information in there. So I'm going to check on the results from this guy. Okay, that's still running. That's fine. What I do typically is I'll take these results, right? I'll take all of my results folders and I will upload this to Google just so that I can read it. So we'll do that now. I already set this rclone up to basically be linked to my Google account. And let's do research. Oh, so and I'm gonna just copy it to G Drive. But I'm sure you have your own mechanism where you have your where you want to save it as well.
Mm.
All right, it says, hey, this is where I'm saving all this information. All right, and then if we wanted to go and look at it, this is where it would be. And I think we're just about done here. Google test. So this is a folder I just created. So here are all my results from like the past couple of days. And let's just open up the one that we just did. All right, so this has a bunch of information. So remember I was telling you before, when you run that automated script, what it does is it'll run it and it'll run multiple sets at once. So what that means is, you see how it has all these rows in here? And look at this first point of accuracy, it's 72%. Okay, so my accuracy thing was off. So it is actually 72%. I don't know why I was saying so it was so low on there, but 72%, right? And at the end, it'll tell us which websites we included. So this is what is known as my classes. All this other stuff is like different parameters. I know it's a lot of information in there, but I needed it for where I was testing before. But what's important is, hey, here are the websites that I'm looking at, right? That's going to be all the way at the end. Your network is going to be here. It says CAT, which means categorical. That's for my fully connected network. It tells me what folder I use and the what directory it was listed in, and all of the sample stuff. But what's going to be the important part here is here are the accuracy, right? So this accuracy is 72% for if I'm just looking at 2 websites.
Okay.
And then what we were seeing before is as we increase the number of websites, that accuracy is going to decrease. All right, did you have other questions? Oh, and you know what I just realized? I think so yeah, the CNN is gonna work. It's just taking a while to run. It's already at almost like 100%.
Okay. Oh, it's very high accuracy.
Yeah, validation accuracy. We'll see what it is when it actually tests the data. So this validation accuracy, what we do when I run this program, you can train it and then you can take like a mock set, which is a smaller subset of data, and verify how it's actually going to perform. That's called the validation data set. And then there's the actual test set that you're using. So this is usually indicative of how the network is going to perform, but it may not be like exactly the same. But yeah. But even here, we're looking at, for the training, it's looking at like 90%. But you also see why I don't always run the convolutional, because it takes a while. So you want to make sure that wherever you're running and however you want to validate it, that you're doing it properly, I guess. All right. So that's all that I had.
Okay, cool.
Let me stop the recording.
Hmm.